Hello guys, welcome back to the channel, and in this video I wanted to talk about radio antennas and how do they actually work. Now that might sound very random, but the main motivator behind actually wanting to talk about this is because I was reminiscing into a project I did earlier this year where basically we wanted to create a very small radio telescope, and this was done by having just a simple setup of two TV dongles, and they were connected through coax cables, and this coax cable was connected to some electronic contraption, which then was connected to an SDR to our laptop. Sounds like a mouthful, but basically using very cheap TV dongles, we wanted to try and see if we could pick up radio signals. And at the end, we were able to do so, and it was really cool basically seeing how this very simple contraption was allowing us to pick up on radio stations from the local region, and that was really cool. So with that in mind, and also with the fact in mind that a lot of technology around us resides around, well, basically how does telecommunication work, I felt like, why not make a nice short little video on the physics of how antennas work. So without further ado, let's get into that. So you've seen antennas before, we've just mentioned some examples, and of course the most popular example would be something like how your TV is able to pick up broadcasts from stations that are very far away. But how does that work? We know that, for example, on the top of your roof or something, there might be some sort of antenna or a radio dish, and that somehow picks up some signal from very far away. But in order to understand how that particularly works, we can reside to some very basic physics, and that is the concept of having two charges, and two charges that are different. So you have one particle which has a minus charge, and one particle which has a plus charge. If I were to draw this, and in the classical picture it would be with these electric field lines going about, because this is an electric dipole, then basically you'd have these field lines going from the positive charge to the negative charge. So if you have an electric dipole, something which you can try doing is, let's ignore all of the other electric field lines and only focus on one of the electric field line connecting the plus to the minus charge. One thing which you can do is we can accelerate those charges and push them closer together. As we do this acceleration, we notice a bend basically in that electric field, and if we do so and put them ever so closely together, then at some point that electric field line is actually going to snap. It's going to break off, form its own thing, and continue to propagate. And that is actually what we want. What we want is that from a charged object, we want to create this propagation, this continuous propagation of some electromagnetic waves, or basically light. So basically by the premise of accelerating charges closer together, then moving them away, and then accelerating them closer together, by repeating that process, you get this continuous generation of electromagnetic waves. That's really cool, because that's already telling you how a transmitting antenna would work. But in practice, how do you create something like this? Well, the most basic version of this would be to have two wires, two conducting wires, and have them placed in this kind of T shape. So you have one wire placed in this direction, another wire placed but facing the other way, and both these wires are connected, so their transmission lines are connected by a generator. This generator is important because what it's going to do is it's going to do some sort of alternating current induction type of thing. So it's basically going to, when it turns on, at one point cause electrons from the first wire to kind of be pulled towards the generator, and electrons to stream upwards towards the other wire. So it's going to cause this type of current, but at another point it's going to flip things around and cause that to happen the other way around. So it's going to cause electrons to then stream from that other wire and then go upwards from towards the original wire. So it does this back and forth, and the way in which you can connect this to the idea of telecommunication is if this generator was connected to some sort of hardware, some sort of other hardware, like for example a microphone. Like if it's someone that is talking that you want to kind of transmit the signal of, then this can be done by having some sort of microphone. This microphone picks up audio signals. So as this person is talking, he or she generates these longitudinal waves in the air. So these vibrations of the air molecules moving, these vibrations causes things to move around in this microphone, and that is translated to electrical signals somehow, and that goes to this generator, which then causes this switching of the electrons moving in this setup in accordance to the pattern at which is being produced by the person talking. So from that, we get basically the same effect of which you have plus charges moving in and negative charges also moving in and then moving out, because as electrons stream, for example, in one direction, it's going to leave this net positive charge on the other direction. So you're going to have this effect of electrons moving away, and as the generator switches or as signals kind of flip, then you get the opposite effect where the where basically the electrons are moving like this, and the pluses are then slowly transferring to the other side. So you keep getting this effect as well. We know now how basically this signal is going to get transmitted, but how do you pick it up? Well, surprisingly, with a very similar setup, you can have the same setup with the two wires, but now instead of generating that electrical signal, you just need a sensor at the bottom of the transmission lines. So the way this works is that if you have the same setup, then an electromagnetic wave comes by, which was emitted itself by some sort of transmitting antenna, and as this electromagnetic wave comes by, then it stimulates the charges in the wire to move. And as this wave continues to propagate more and more towards the wire, then this motion of the charges kind of switches. So as this propagation continues to happen, you get the electrons in the wire moving in a different way. And this is, of course, they move not only on this outer T place, but they also go downwards towards the transmission lines. This is picked up by whatever sensor you have on the bottom, and you can put something, for example, like an amplifier, which kind of amplifies the signal to be something which a device can recognize. For example, a radio can recognize this then. And this is how your device can kind of interpret this electromagnetic wave that is being sent out into some sort of audio or visual like signal. And that's really cool, because that really intuitively tells you how your TV is able to pick up like these images that are being broadcasted from stations very far away, as the antenna on your rooftop or something picks up this electromagnetic wave, sends it through some sort of current, and that is being picked up by your TV. Or in the case of radio, especially old-fashioned radios, like it's even more directly seen, as radios have their own antenna, and this is the reason why if you own a radio, you need to place it in a manner that is so strategic that it is not being blocked off from everything. So for example, it would be the most ideal to place your radio outside, as it's then going to very easily pick up these radio waves that are being broadcasted. I like how basically this very classical notion of electromagnetism is able to explain something which is fundamentally important in our day-to-day lives, and that is telecommunication. Even in our telephones, we have these built-in sensors which are able to pick up signals, electromagnetic wave signals, from things which, for example, need to send out like Wi-Fi to our telephone, such that we can have internet and things like that. The exact way it is built in our phone is of course more complicated, but the premise is still the same. But of course, not only does it have these very practical uses, but it also has uses in fundamental research. For example, one thing which I particularly find interesting is its use in radio astronomy, as I've kind of alluded to at the beginning of the video. In radio astronomy, you can typically, if you imagine radio astronomy, you imagine these huge dishes, which you might have seen images of. For example, if you've seen the movie Contact with Jodie Foster, these huge dishes are able to pick up radio waves from faraway celestial objects, because faraway celestial objects, some of them are radio emitters. So they emit light that is of the wavelength of radio waves, And this is really nice because this means that, for one, you can do your observations even during daytime. Like, you don't need to worry about it needing to be dark such that you can observe your stars or your deep sky object. You can do so even during daytime because radio waves, well, they scatter much less as they come through our atmosphere. And this also makes them really useful for studying things with, like, for example, quasars. Quasars being these actively feeding black holes at the center of many different galaxies. The reason it makes them useful is you might think, well, actively feeding black holes, doesn't that imply some very cataclysmic event happening? You wouldn't be wrong. It is a very high energy process, and as a matter of fact, astronomers do try to observe these things in more high energy end of the electromagnetic spectrum, but they do so with space-based telescope like the Chandra telescope, and not with ground-based ones. Because with ground-based ones, if you're trying to look at X-ray, that thing is going to scatter so much in our atmosphere that the signal that you're going to get is going to be meaningless for the most part. So what they then prefer to do with ground-based observatories is with radio telescopes to point them in a direction in the sky, and not only have one radio dish but have many radio dishes pointed in the direction, and each of them pick up something about that radio source, and through some very fancy techniques like cross correlation and some signal processing, you can create this image of what your radio source is supposed to look like. And very often it is a very insightful thing to study radio emitters in this sense, and it's one thing which makes radio astronomy, I find, to be so just incredibly fascinating. Like the combination of both the technical and hardware aspects of it, as well as some of the theoretical underpinnings that goes with it. But besides me geeking out about radio astronomy, the way radio telescopes work is by the same working principles which we've just mentioned with any other antenna. Like it could be like a Yagi antenna, which is the one which you very often see. And Yagi antennas, I gotta say, is not only interesting for like TV, like broadcast, but also you can go on YouTube and search up like people making their DIY antenna, and you'd see these very amazing like contraptions which people are able to make up, because making antennas isn't technically so difficult. You just need the right conducting material, and you need the right schematics, of course, and you can make your antenna, and people can do crazy things like communicate with people from the International Space Station. Like if you know when exactly the International Space Station is passing like in your region of the sky, you point it in the right direction and try to create a broadcast, you can technically speak with astronauts, and that's really cool. You should definitely check out some YouTube videos on that. But with radio telescope, the principle is the same, and for example, in the case of the project I did, the TV dongle acted as the radio receiver, like that radio receiving antenna, and the dish that you typically see with radio telescopes is to simply focus all of the light that is coming from the sky onto your radio emitter. Sorry, I was mentioning radio emitter, I meant radio receiver. If you think about it, your radio receiver is this very small thing. It has a very small, you could say, area at which it can capture light. So if you want to maximize the efficiency of this thing, then why not create this hyperbolic shape thing which can then conically concentrate everything towards that sensor. So I hope you found all of this to be particularly interesting, whether it be the more practical side of things or just the more physicsy side of things. Let me know. I'm very curious, and I want to know if I should create more content like this. And also I hope you're just enjoying your day and having a wonderful weekend. Hope to see you all very soon, and bye.